Today we're discussing factoring of a specific type of pattern. That pattern is called the difference of squares. First of all, it's important to be able to recognize numbers that are perfect squares. So here I have a few listed. I mean, this is obviously not all of them, but just the first 10. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. All of those numbers are perfect squares, and difference means subtraction. All right, so before we begin by factoring, we're going to do our warm-up where we do the opposite of factoring, which is distributing or multiplying. So in our first warm-up, we're multiplying x minus 5 times x plus 5. So to multiply a binomial times a binomial, we distribute the first term. So we'll be distributing the x to x plus 5, and then we distribute the second term. So we'll be distributing the negative 5 to both terms. So x times x gives us x squared. X times 5 gives us 5x. And then distributing the negative 5. Negative 5 times x gives us negative 5x. Negative 5 times 5 gives us negative 25. Some people like to use the acronym FOIL for when you're multiplying a binomial times a binomial. All that means is first term times first term. That's what gives us the x squared. And then our outside product is the x and 5, these two terms that are farthest apart, called the outside product. And then inside product, these two terms that are closest together, give us that negative 5x. And then the L stands for last. The last term in this set times the last term in that set give us that negative 25. After we distribute or FOIL, we combine like terms. The plus 5x and minus 5x combine to give us 0x, so that leaves us with x squared minus 25. All right, so let's do the same with the second binomials. First terms multiplied together, 3x times 3x will give us 9x squared. Outside product will give us negative 12x. The inside product gives us plus 12x. And then the last term times last term gives us negative 16. Combine like terms, the negative 12x plus 12x is 0x. So that leaves us with 9x squared minus 16. So these resulting products over here are called the difference of squares. So difference, we're subtracting. The first term is a perfect square. The last term is a perfect square. So if you notice that you have the difference of squares, you can factor that by, let's look back here, look at what the factors were. They're the same, almost exactly the same, except one is a minus and one is a plus. So our factors were a sum and difference of the same two terms. All right, so if we've got terms squared, a perfect square term minus another perfect square term, the factors will be the sum and difference of their square root. So notice here we've got a squared, but in our factors we just have a to the first power. That just means we took the square root of that term. And then notice here we've got b squared, but in our factors we just have b to the first. That means we took the square root of the second term. So that is your pattern. So it should be pretty simple, as long as you can recognize numbers that are perfect squares and you can take their square roots. If we look at number 1, first term is 25x squared. The last term is 36. We're subtracting them, so it fits our pattern. So our factors will be, first, the square root of our first term would be 5x. And then the square root of the last term is 6. So remember to have a plus and minus sign. So on to number 2. Square root of the first term is 2x. The square root of 1 is 1. So our factors are 2x plus 1, 2x minus 1. Number 3, we do have the difference of squares. The square root of our first term would be 4x squared. The square root of our last term would be 3y. So I was noticing that this is x to the fourth, but I don't have the x squared here. If I distribute 4x times 4x, would not give me 16x to the fourth. So I have a mistake there. I'm going to go back and correct right now. That should be 4x squared. should be 4x squared. Sorry about that. Okay. That. So 4x squared times 4x squared. These first terms should multiply together to give you 16x to the fourth. And then plus 3y and minus 3y add together to give you that negative 9y squared. In number 4, we've got 144x squared minus 100. Those numbers are both divisible by 4, so we have to factor out a 4 first. So if I divide both of those by 4, we get 36x squared minus 25. And 36 and 25 are both perfect squares. So again, we have the difference of squares. So remember your pattern that it'll factor into the sum and difference of the square roots. So bring down your 4 that you originally factored out, and then the 36x squared splits up into 6x and 6x, minus 25 splits up into plus 5 minus 5. Number 5, both of those terms are divisible by 2. So I'm going to factor out the 2, and then we have the difference of squares. So factor that using your pattern, where we have the sum and difference of the square root of your first term and square root of your last term. 147 and 243 are both divisible by 3. So we factor out the 3, and then we have the difference of squares. So splitting that up, the square root of 49x to the 6th would be 7x cubed. Square root of 81 is 9, so it factors into 7x cubed plus 9, 7x cubed minus 9, and we got to make sure, remember to bring down the 3 that we originally factored out. Bye.